All right, this lesson is on Module 5, Topic 2, Lesson 1. So the first lesson that we're working on is the book of our very last topic that's working on volumes. And this specifically, this and the next lesson will be on volumes of cylinder, which we did do some guided notes on. So we have, I would say, a fairly good understanding of it. But we had to kind of see how do we fare with, the problems that the book gives. We're going to be starting on page 673 and going to 678. So we're going to actually start on the warm-up, which goes over two topics that we are familiar with. It says determine each area or volume, and we're going to use 3.14 as pi. So have your calculator handy to check the math here. But let's go to number one. It says the area of a circle, or when we're thinking of the area of a circle, it's the space that's inside. And we're looking at square units. So it looks like we're saying that the radius of this circle is 8 centimeters. So this square, well, we could say that this is 8 right here, 8 centimeters. This is what we call as 1 square centimeter. I'm probably not drawing it to scale. It's probably got to be a little bit smaller. But we're trying to ask ourselves, how many of these would fit into this square? Or this amount of paint in terms of this bigger figure of the circle. So we have to use the formula for the area of a circle, which is A equal to, I'm going to put pi r squared. And we'll plug in what we know. So we'll plug in that the radius is 8. So this will be pi times 8 and then squared. Now we have to figure out how to simplify this, and we always go through order of operations, right? So for GEMDAS, the operations that are exhibited here, we have an exponent because we have an exponent of 2, and then the pi is next to the 8, so that indicates multiplication here. You won't always see that dot there, but let's go through this, which is 8 squared, which means 8 times 8, which is 64. I could write pi times 64, but typically put your coefficient, your numerical coefficient in front. So put 64 pi. And this tells us we multiply 64 times pi, so we'll use our calculator for that. So 64 times 3.14, enter 200. And what we could say is 296 cents. But this is in terms of square centimeters. So 200.96. Since it doesn't tell us where to estimate, we could write it like this. To the nearest hundredths place. And this is in terms of square centimeters. And how we're going to write that is centimeters with a second exponent. But this is our final answer. You might also see the answer written like this, where you have it in terms of pi, but if it tells you, use 3.14 pi, you got to multiply by 3.14. Okay, so nothing new there. This just gives us the circle. Let's go to the volume of a rectangular prism. So rectangular prism, we're kind of looking at a box here. Imagine a three-dimensional figure. Okay, we're saying that the length is 2 feet, width 3.1, and height is 6.08 or 8 hundredths. And we know that the volume of a rectangular prism is length times width times height. Now, it actually doesn't matter which order you go through these numbers, even though they do give it in order of length, width, height. Because in the end, multiplication is commutative, meaning the order doesn't matter. But let's put V equal to 2 feet, 3.1 feet, and 6 and 8 100ths of a foot. Okay, so let's multiply. So we have 2 times 3.1 times 6.08, $6.08. So that is 37, and we're gonna round this to the nearest hundredths place. Now the 9 is in the hundredths place right now, so we look at the thousands place, 6. That 6 would tell this 9 to go up. Now if it goes up, that's a 10. That's 10 hundredths. So that would actually make this 0.6, and we would actually make that tens place actually go up. So think of this as like $37.70 since we're rounding to the nearest hundredths place. Okay. So V equal to $37 and around 70 cents. For 70 cents, you could just put the 0.7. You don't need to put the 0. You can, but you don't have to. And this is in terms of cubic feet. Okay. And then lastly, something I do want to talk about is a student asked, why is this feet cubed or cubic feet here? The reason is because we have foot times foot times foot, right? And if we have foot times foot times foot, how many of them are there? It is 3 of them, so foot to the 3rd power, right? Whereas over here, we just multiplied 8 centimeters times 8 centimeters, so that's why we get 8 or centimeters squared or square centimeters. So that's why we just have an exponent of 2 versus volume, which is a 3. And volume will always have that cube, because what you're asking yourself is if you have a tiny cubic foot like this, you're asking yourself how many of these would fit into this? How many tiny blocks would fit into this bigger block? Okay, so we're looking at 3 dimensions, length, width, height. Okay, now let's go to, we're actually going to skip the next page on getting started. We're going to actually begin with activity 1. And this lesson we'll be going over activity 1 and activity 2. All right, so this is just a basic understanding of what is a cylinder. A cylinder is a 3-dimensional object with 2 parallel congruent, so parallel congruent circular bases. It's just saying that the top circle is the same thing as the bottom circle and that they're parallel to each other. They will never intersect. The radius of the cylinder is the distance of the center of the base to any point of the edge of that base, right? Just from here to here, but also here to here. From our perspective, it may not seem like it, but those are actually the same distance, right, as this one as well. Right, all equidistant to the center. All right, and the radius of the cylinder is the same on each base. And the height of the cylinder, the height is the length of the line segment drawn from one base to the other base. So that is from here to here. That's the height. You can also say that over here to here, or even like, let's say I go from here to maybe like that's a corresponding part. All those should be the exact same size. We can see, yeah, it's about the same size as these other two. Okay, great. And they're perpendicular to both bases. Number 1, write a formula of the volume for any right prism and define all variables used in the formula. So there's a formula you could use here. It's V equal to capital B times lowercase h. And this is where, right, we know where V stands for volume, H represents the height, but capital B is different than lowercase b. The capital B is the area of the base. We're going to say polygon. Polygon, so examples of polygons: triangles, quadrilaterals, pentagon, hexagon, septagon, or we can even have circles here as well. So the base of this is that we have a circle. We're actually going to make this conjecture here. So number 2 is make a conjecture about how you calculate the volume of a right cylinder. So meaning that it intersects at a right angle. So when we say capital B times H is we're looking at what is the area of this, which is a rectangle. So this is already base times height. And then we multiply by the height of the entire figure. So although we know it's length times width times height, at least how I wrote it down, it could be capital B times H. And that capital B is actually a lowercase b and a lowercase h. The height of the polygon versus the height of the cylinder. Okay. So here, a conjecture is a guess. A conjecture, so the conjecture that we could say is the area of the base of the circle. So I'll just say area of the circle times, let's put x, times the height of the cylinder. I'm going to abbreviate here as just CYL. All right. And let's go to the next page. So it says, consider the cylinders that are shown. The radius of the circular base is 5 units, and the height is 8 units. Okay, number 3, suppose there is a circular disc of a height 1 unit at the bottom of the cylinder. Okay. So it looks like this bottom one right here, or one to the right. Calculate the exact area of the top of the circular disc. So it's exactly the same. All right, we're going to say area is pi r squared, but we're going to have pi, the radius is 5 units, and then squared. Right, 5 times 5 is 25, so we're going to say this is 25 pi. Okay, and we're actually just going to leave it at that. We're not going to multiply by 3.14, so we're going to say that this is square units. I'm going to write it like that. Okay, and then B, how many congruent circular discs would fill the cylinder with the exact volume of each disc? Okay, so because we're saying that this is 1 unit high, how many of these, like hockey pucks, I guess, would it take to fill up the entire thing? So with this, it would be 8 circular discs. I'm just going to put 8 discs would fit in the cylinder, because the overall height is 8 units, and each disc is 1 unit in height. So each disc has a volume of, we're going to say that this is 25 pi square units, or sorry, cube units. Because although we're finding the area, we know that the height is 1, so it's 1 times 25 pi, which is just 25 pi, but this will be cubic units. Okay, determine the total volume of the height. So we're going to take 8 times 25 pi. We could just think of, right, 8 times 25. So how much is 8 quarters? That is equal to 200. It's $2. And we're going to say that this is 200 pi cubic units. So what we did here, the strategy is we multiplied the area of each disc by 8, since there would be 8 all lined up. And then for number 4, it says write a formula for the volume of a cylinder, where V represents the volume, R is the radius, and H is the height. We've already done this in our guided notes, but as a review, this is just V equal to pi r squared times H. We don't always need that dot there, but I like to put that dot there so that we know that this represents, I'm going to just draw it here, the circle. And if we think about this as I think I expressed this as, this is like, think of this as a baloney. If we're thinking of how many balloons we're stacking up, that gives us the volume of the cylindrical object. So it's whatever the circle is times the height. Okay, let's move on to activity 2 on the next page, 677. Then we just have 2 more pages to finish up activity 2, and that'll complete the lesson. So it says, in this activity, you will use what you know about cylinders to solve real-world problems. And then here, there's some information that's given to us. It says the director of the marketing department at the Rice's Nice Company sent a memo to her product development team. She requested that the volume of the new cylinder prototype equal that number in terms of cubic centimeters. Okay. And then number 1. 2 members of the marketing team claim to have created appropriate prototypes, but they disagree about the dimensions, so like the height and the width. And then Cassandra designed the cylinder prototype on the left, so it's Cassandra on the left. Robert designed the one on the right, who is correct. And what would you say to Cassandra and Robert to settle their disagreement? Okay, so which one is correct and which one is incorrect? So let's use the formula for the volume of a cylinder to calculate for this. Since it doesn't say in terms of pi, we're going to have to multiply by 3.14 and see what we get. All right, so let's start with the one on the left. So this is Cassandra. Let's put CAS, and this is Robert. I'll just put Rob. Okay, let's do some scratch work. For the first one, right, V equal to pi r squared times h. Let's put pi, the radius for this is 4, right here, times 12, right here. Okay. Now, we know that oops. Always first, you have to square the number, so multiplying 4 times 4. So 4 times 4 is 16. Let's do 16 times 12. I don't know that off the top of my head, so we're going to use our calculator. 16 times 12. 192. Okay. 192. Whoops. 192 pi, and now let's multiply 192 by 3.14 times 3.14, 60288. I'd like to see that. Okay. So final answer we're going to say is the volume is 602 and 88 hundredths of, this is cubic centimeters. Okay, so this is what Kaz has. Now let's check what Robert has. Right, like, so you can think of a guess or just take a guess here. Right, do you think that this is going to hold more rice, less rice, maybe the same amount of rice? Yeah, so think about that. Okay. So this one, we're going to put V equal to pi r squared times h. So the radius is 8. The height is 3. All right, let's multiply this. 8 squared is 64. 64 times 3, let's do that out to the side. All right, 4 times 3 is 12, carry the 1. 3 times 6 is 18, plus 1 is 19. So we get 192 pi, and maybe that we notice that that's actually the same thing right here. So, right, multiplying 192 by 3.14 for pi, we know we're going to get the same exact answer. So it turns out that Rob also has the same thing as 60288 cubic centimeters. So they both have the same thing. Okay. So calculating the volume for each of the prototypes, this would satisfy the director's memo. So what would we tell them? We tell them that they have different dimensions, but they have the same volume. So we're going to say different dimensions, but same volume. Where they occupy the same amount of space, technically. All right. And then number 2. So number 2 says use, again, 3.14 as pi. We're going to use it to solve the problem. It says a cylindrical swimming pool has a diameter of 30 feet. So I think 30 feet, I believe that's the width of the class, if you want to gauge it that way. So from end to end, I don't know, maybe you can imagine like almost our class, but like a circular object, circular figure as the pool. And the height of 5 feet. So 5 feet, not that, I wouldn't say not that tall, like, I don't know, I think average height is like 5'5", 5'6". So maybe this is like, probably you'd be able to stand in this pool. Okay, I'm gonna do a bad job drawing this though, so let's do so 5, it's a lot wider than it is tall. Let's go like this. Oh, yep, that's pretty bad. Okay, anyways. Now we know that this is 5 feet tall. And it doesn't give us the radius actually, it gives us the diameter. So we're gonna go like this. The diameter is 30 feet. Now, in the formula for the volume of a cylinder, because this is still a cylindrical object, we want the radius. So the radius is not given to us yet, But if you're ever given the diameter, you want to find the radius as the center to the edge, which is half the diameter. So the radius, it would be half of 30. So our radius for this problem is 15 feet. Okay, so we're going to put 15 feet right here. All right, so V equal to pi. 15 goes for r squared times 5. Okay. Now, this is a math fact that I know, so I'm not going to use the calculator. 15 squared, 15 times 15 is 225. And I'm going to multiply that by 5. 5 times 5 is 25. Oops, carry the 2. 5 times 2 is 10, plus 2 is 12, carry the 1. 5 times 2 is 10, plus 1 is 11. So we're going to have V equal to 1125 pi. And this is cubic feet, but we'll write that at the very end. Let's multiply 1125 by 3.14. 1125 times 3.14. All right, so 3532.5. 3532.5 cubic feet. We could put a comma here because this is technically 3,000. So 3,532 and 5/10 of a cubic foot, or cubic feet, in terms of how much water you're going to need to fill up this cylindrical swimming pool. Okay, all right, great. Let's move on to the last page. Now on to 678. Number 3, how many milliliters, so this is typically abbreviated as ml, capital L, of liquid do you need to fill a cylindrical can with a radius of 3 centimeters and a height of 4.2 centimeters? Now, whenever you're not given a visual diagram or just a figure, I would recommend draw a figure, even if it's as terrible as mine. But how many milliliters? Okay. And if you're not sure how to draw this, like let's use our numbers to help us. The radius is 3 centimeters. The height is 4.2 centimeters. So maybe I can just draw a circle here. Draw a circle here. Go like this. We'll say this is 4.2. We're given the radius as 3. And let's plug in. This will be pi 3 squared times 4.2. All right, 3 times 3 is 9. Let's do 4.2 times 9. This is 18, carry the 1. This is 36 plus 1 is 37. We account for that place value here, so we're going to put it here. So the volume is 37.8 pi cubic centimeters, but let's multiply by 3.14. Actually, I'll just give you the answer for this one. If you multiply by 3.14, you're going to get 118.692 cubic centimeters. Okay, I'll leave the next one for you. This will be a you do. And we'll work with these objects here. Some examples here. Let's do, this is where we're trying to find a dimension that we don't know given the volume. So we're saying that the volume of each of these solids, they all hold 500 cubic centimeters. So all of these objects hold the same amount. They take up the same amount of space. But let's apply our understanding. We're gonna go through A and B. We'll leave C as a you do. Okay, let's go through A. Now, it's really important that when you go through these problems, you know the formula for these various objects. So for a cylinder, we know it's pi r squared times h. For a rectangular prism like this, we know it's length times width times height. And for these, we all know that the volume is 500. So we're going to plug in. Normally, we're not used to plugging in for volume, but we are. Let me put this line. Okay, so we're just gonna put 500. Not gonna put cubic centimeters there. We'll leave that at the just off to the side. We do know we don't know our radius, but we do know this. Even though it's on its side, the 13 centimeters is the height. Okay, so we're gonna put pi r squared times the height of 13. And when you plug in, you only want one variable, one unknown. And in this case, it's r, right? We know what pi is. Pi is 3.14. Actually, let's rewrite this where we have 3.14 r squared, and then I'll put times 13. Let's multiply our numbers together here. 13 times 3.14. Okay, 4082. And we have radius squared here still. We still have 500. And I can't do anything with the radius yet because we have this number that's multiplied to it. So let's divide both sides by this number. So divide both sides by 4082. Right, this will go away. We'll be left with r squared on the right side. So 500 divided by that, divided by 40.82. Yeah, really long number, but we're going to round this to be 12.25. Technically, when you're rounding, you wouldn't put an equal sign here. You would put an approximately equal to, so 12.25. And at our last step, if you remember, right, we want r by itself. So just like with Pythagorean theorem, you would get rid of the square by taking the square root of both sides. Okay. And the square root of 1225. So 12.25 square roots. So that's 3.5. Okay, and our answer is in terms of centimeters here, not cubic centimeters, because we're not finding the volume. But let's put that our answer, 3.5 centimeters, is the radius. Okay, so that did take some effort, but I think, right, we know all the skills and tools that needs to be applied here. Right, first of all is remembering the formula, knowing where to plug in, and then from there it's inverse operations. And a couple of operations at that. Okay. All right, let's go to the next one to finish this up. Okay, so it doesn't matter what you call the length, width, and height, except we do not know what the height is. I mean, you could say that this is the length, this is the width. I mean, it all depends, because, like, let's say I move it and it looks like this. Right, then what's the length and width and height from there? So we're just going to plug in 3 for something and 4.5 to something. Oh, sorry, we're not going to plug in B. Our volume is 500 from the problem right here. So 500 equal to, we'll say 4.5 is the length, 3 is the width. We have no idea what the height is. So if you multiply these two numbers together, what's 4.5 times 3? Oops. 4.5 times 3. Oh, sorry, I didn't clear that out. 13.5. Okay. All right, let's divide both sides by 13.5. That'll give us our answer. 500 divided by 13.5. So 37, we'll round this to that 3 to a 4, since that 7 in the thousands place is bigger than 5. And since we do have to round, we're going to put approximately equal to. So this is, I'm going to switch it. I'm going to put that the height, I'll put h over here on this side, is 37.04, and this is centimeters. Okay. All right, I'll leave the last one for you. Let me know if you'd like for me to check.